Ah. So Kelvin's double bridge. Kelvin's double bridge. So what is a Kelvin bridge? Last class you have learned what is Kelvin bridge. A Kelvin bridge take into account the resistance of the connecting leads and the contact resistance. When you connect two wires, at the contact there is some different resistance. It also offers resistance that is more complex physics. So that comes in the calculation if the unknown resistance is having comparable value to this contact resistance or lead resistance. So in that case, Wheatstone bridge will show some errors. So to remove those errors, we further develop the Wheatstone bridge and study it as Kelvin bridge. Now Kelvin bridge is a basic idea that I have given, in which the lead is divided into two sections and the ratio of the resistance of these two sections is proportional to the opposite arms. But that is basic idea. In practical, we will make Kelvin's double bridge. Okay, so what is a Kelvin's double bridge? Double means it has two sets of arms. What are resistors arm? Two sets. One is the original, other is a second set. So first set and second set. So if I will draw a come in. No need to ask. Always try to make good figures. So here what we do, here we change the connection change it. मुझे लगा मैं दूसरी किताब का बना रहा हूँ फोटो. It doesn't matter, I am showing upward. Okay, up down भी दिखा सकते हैं. You can show downside also. So this is R3, this is Rx, this is a standard resistor. Now here comes the galvanometer. And we have two more arms. One is L, other is M, and this is the connecting lead having resistance Y. So this is a Kelvin double bridge. Here first set of arm R1, R2 are outer arms first set, and L, M are inner arms. L comma M are inner arcs. Okay, these are the names. These are the names. Nothing big. Okay, you first set and you can name it first set and second set, or outer set and inner set, because it is coming inside the bridge. So it is inner arms and these are outer arms. This is the standard resistance. This is a unknown. This resistor is having, which is to be found. Okay. Now, under what condition? There is a Kelvin's double bridge condition. Kelvin's double bridge का एक condition है. There is a condition, ठीक है, which we have imposed, which is this bridge circuit has to follow, okay, or it will be designed, is that these two sets of arm are related in this way. We are designing, so we are putting a constraint, we are putting a condition that inner arm and outer arms are in this ratio. So R1 by R2 is in ratio with L by M. This is condition that we have imposed. Means we will take care of this condition. If we will take care of this condition, we will get the resistance more accurate value in comparison to Wheatstone bridge. Far more accurate. Okay. So this is an imposed condition. And if suppose I will not consider it here, but when I will derive, there also you will need this condition to eliminate the other factors. So suppose I am not telling you here this, still you will generate this condition at the later stage. You know, if this will be the required, if this will be the condition, then we can express Rx in terms of this resistor. So under this condition, Rx will be equal to this. Under this condition, Rx will be came as this. So suppose I am not knowing this condition. Either I am the god of the circuit, so I am knowing, I have intuition, or suppose I am not knowing. So I will go analytically and I will get a big equation, okay, complex equation. And from there I will see that if I will create a situation like this, condition like this, then I will cancel out other extra terms and this clean equation will come. So suppose I am not telling even you, it will come in the equation. Okay, so main thing is to solve the equation for Rx, to solve the bridge circuit for Rx. To solve means to find the unknown, or to express the, or to get a expression for Rx in terms of other parameters. Okay, so even I will not telling you, don't worry, this will come. This is first thing, and second thing is balanced bridge condition. Balanced bridge conditions. So there are two conditions, condition 1 and condition 2. So under balanced bridge, suppose I am marking the name A, B, A, B, C, D, E, F. A, B, C, D, E, and then F here. First I name the complete loop A, B, C, D, E, and then here this term as F. Okay. So under balanced condition, Ig will be 0. Current through the Ig will be 0. It means voltage at the A will be equal to voltage at F, voltage at A will be equal to voltage at F. So these are the condition from where we will start solving the bridge circuit. Okay, now because this is a balanced condition, the galvanometer has no current flowing through it, we can take it out for the purpose of circuit solving. Okay, not the purpose of measurement ki okay, eliminate and remove this. This will be there, but for our in mental world, in mind, I will remove this galvanometer for make the circuit look easy for calculation purpose. Fine. So note it down. So I will come up. So what you will see in the balance condition. Acha. है ना, लाइव लेक्चर का यही है कि आदत बन जाएगी। बाद में आपको कोई दिक्कत है तो ज़रूर वीडियो देखिए, पॉज करके देखिए, नोट्स बनाइए, सवाल पोस्ट करिए, कोई डाउट्स हैं तो। सो इफ़ आई विल इम्पोज द कंडीशन, बैलेंस कंडीशन, आई विल जस्ट रिमूविंग द गैल्वेनोमीटर फॉर कैलकुलेशन पर्पस। ठीक है, so for calculation purpose I am seeing this circuit like this. This is R2, R1, this is E, this is R3, this is Rx, this is F, A, B, C, D, E, F, and this resistor is Y, this is L, this is M. Fine. After removing galvanometer for the calculation purpose, to make circuit looks less complex. So circuit looks less complex. Nothing more than that. So I said that VA is equal to VF. Okay. Now this is a parallel circuit. This is a parallel circuit. See what I want to see. Now I can see. Now you can see me. है ना? तो the bridge circuit says, देखा है ये मूवी? नहीं देखा है. Now you can see me. ठीक है, now you can see me. So how you will see? You will see, okay, this is a resistor, this is R2, R1, and then parallel resistor R3, M, L, Y, Rx, something like that. Why is the resistance? Connecting lead is I am showing now as a resistance. It will have resistance 0.001 ohm ho या 1 lakh ohm ho. The symbol is same na. So here it was a connecting lead. So it is a connecting lead resistance of connecting lead. है ना, this is. So this is the circuit. Which is more good, this or this? Both are bad. This you don't think to solve. It is not looking charming, है ना, looks more harming. यही है ना. So VA is VF. VA is VF, and this is B, this is C, this is D, and this is E. So which circuit I go? This circuit or this circuit? किस circuit से आगे चलूँ मैं? इससे ठीक है या इससे ठीक है? इससे ठीक है. इससे ठीक नहीं है? But think, try to think with this also. Okay? Make both. किसको? R1 R2 is not, was not in series. Now this is in series. हाँ, यहाँ पे सीरीज में वही है. I am just showing this ना. Yeah, now it is in series with under balance condition. It is in series. But हाँ लिख सकते हैं, but I am not going there. Okay, because we are, see, we can do several things. We can contract this, contract this, contract this. Then where we want to go? Suppose we are saying I will make it equivalent R1 plus R2. We can make also this equivalent. That is good. But where we want to go? What is our target? Our target is not to reduce the circuit. Our target is to find the Rx in terms of other parameters. So recall the Wheatstone bridge. What I have told you, the methodology. In books, they are going through other way. They are also good. But I will keep the thought process same. In Wheatstone bridge, how I approached, if you remember, what I did, I said that this is a parallel circuit. So if a current is coming from here, it will be like I1 and I2. Okay, we did this. And second thing we did, that the voltage drop from A to B is same from F to, from B to C is from B to A. So I am writing first this for a parallel resistor. Okay, I am omitting this. So for me, if I am saying VBE, voltage drop between B and E is equal to E, and that is I1 into, suppose this resistor is R1 dash. So I1, R1 dash is I2, R2 dash. If I am telling this as R2 dash for the time being, because there is less space. If there is more space, I will write. So first thought is this. This was my first thought in Wheatstone bridge also, and I took these two terms. So I took this condition, that I1 into this resistance is equal to I2 into this, and then I1 I express in terms of VB minus VA, and I2 in terms of VB minus VF. Because so I will cancel it out from both sides, and we will left with only resistance, no current, because we do not require current in the measurement. Okay, remember the methodology of Wheatstone bridge, from where I started, because in books may you find a easy way, but the thought process is broken. So if you will remember or recall the way I did in the Wheatstone bridge, that I first put all the conditions, then I started from here, that the resistance in this R, voltage drop is equal to voltage drop in this R, and then I replace this I1 and I2 with the voltage drop such that both voltage drop cancel out. So I1, if I say this is I1, so I1 will be VB minus VA by R2. VB minus VA by R2 multiply the resistance is R1 plus, चलो यहाँ पहले ऐसे कर लेते हैं, थोड़ा शॉर्ट डालेंगे. यहाँ देखते हैं I1 into R1 plus R2, this side will be equal to I2 into R3 plus Rx plus the parallel combination of this. R3 plus Rx plus parallel. तो आपने जो कहा, what the J said, कि I want to look it as a equivalent resistance. So R1 plus R2, and this will be R3 plus Rx plus parallel combination of this. So this looks clumsy, it looks complex, but that is algebra. The electrical engineering is not complex, that is the algebra. So if you have solved so many equations, then you can come over with this. Now I will replace I1 and I2 with a voltage difference, and I will cancel that voltage, so only resistance will be there. So I1 is VB minus VA by R1. I1 is VB minus VA. See this. I1 is VB minus VA by, sorry, R2. R2 na? VB minus VA. I have to replace I2. So I2 will be VB minus VA by R2. Now what will be the I2? I2 is coming here, but it is dividing. So I am saying this is I21 and this is I22. So directly I cannot relate VB minus VF. So I will write I2. So I2 is VB minus VC by R3. I will keep this. I2 is VB minus VC by R3. But what we want to look this, because VB minus VA is VB minus VF. So I want here VF, not VC. Okay, so let's see how I will bring this VB minus VFs. Fine. So for the time being, concentrate on this portion only. Okay. Concentrate on this portion. I am highlighting this portion. Fine. दिख रहा है ना? For the time being. Okay. So use the current divider rule here and correlate this I21 L, M and Y. So I want to replace VB minus, I want to create VB minus VF. So VB minus VC is I2 into R3. That is one thing. Let's see VC minus VF. Because when I will add, I will get VB minus VF. VC cancel out, VB minus VF. So VC minus VF means this point minus this will be what? This will be I21 into M. This is M. This is M. L, M, F. So that will be M into I21. And if I will express I21 in terms of I2, I can replace here I2. Okay. So what will be I2 in terms I21 in terms of I2? Use current division rule. Tell me. Using current division rule, I21 will be equal to Y by Am I good? Yeah, I am good. Okay. So replace this I21 with this I2 and solve VB minus VF. So what you will get? That is the problem of the small board. That is the problem small board. I cannot write all the things at the same time. So from I am rubbing from here. Yeah, come. So I am rubbing this because it is not required now. I am totally dependent on the equation. I don't need this circuit now. I don't need this. Okay. I need this. I am replacing also this because I have used. So only I am left with these two things. Fine. So keeping this, that I have. So I because we are V. So we have one thing is I1 R1 plus R2 is I2 R3 plus Rx plus L plus M into Y by L plus M plus Y. So let's rub this and VB minus VC is I2 R3, VC minus VF is I21 into M. So M into I21 from here will be Y by L plus M plus Y into I2. Okay? I am replacing I21 using this. So M को ऐसा ही छोड़ दिया and remaining this. Got it? So I rub this. So we have these two, and now I will be adding these two equation. So this will cancel out and will be VB minus VF will be equal to I2 into R3 plus My by L plus M plus Y. VB minus VF. Okay? So major equation is this, master equation. Master equation doesn't mean my equation. Okay, this is also your equation. Fine. So if I will replace I1 and I2 because I have got I2. Okay. So what will be the So इधर लिख देते हैं Kelvin's double bridge. So I1 from the circuit you can see in your copy if you have made that circuit. So I1 is VB minus VA by R2. I1 is VB minus VA by R2 into R1 plus R2, and I2 is here. I2 is VB minus VF by this R3 plus M Y L plus M plus Y. Woody Baba. It's a big giant equation. It's so frightening. R3 plus Rx plus L plus M Y by L plus M plus Y. Fine? Okay? So it looks so frightening. Are you fearful? I was very fearful. Still I am fearful. But that cannot stop us. We have to go ahead. Okay? तो स्वच्छ इक्वेशन अभियान के तहत हम इसको साफ सुथरा करेंगे. So to keep it swatch, we know that VB minus VA is equal to VB minus VF. That is from balance condition. If you forget, just for you to remind, this was L, this was M, this was F, this was A, this was B, C, D, E, and this was E. So because this and this are at same potential, and this is the same, so VB minus VA is VB minus VF. So that's why we can cancel it out. I am putting arrow and I am telling the value that it is 1. This cancel out and here remains 1. Okay. So in such equation abhiyan, we got R1 plus R2 by R2 is 1 by R3 plus My L plus M plus Y into R3 plus Rx, keep them together, L plus M into Y by L plus M plus Y. So here it looks, if I will multiply, something will also cancel out, है ना, थोड़ा सा और साफ सुथरा हो जाएगा, we will make more clean, ठीक है ना. So here we will make it clean. This is 1 plus R1 by R2 is equal to, I am keeping this together, so R3 plus Rx by R3 My L plus M plus Y plus, when this will come here, this will be L plus M into Y by R3 plus My L plus M plus Y into L plus M plus Y. See this. Okay. So what we will get? We have to again change the page. So I have to again start from here. Please write it down. Akhileshwar na? Akhilesh na? Write it down. Write for your friend also. Write. Okay. अगर बगल वाला नहीं लिख रहा होगा तो तुम ही 2 बार लिखना अपनी कॉपी में, तुम ही से लिखवा देंगे फिर. Okay. You have to go twice or thrice on a way if you want to get acquainted. If you are coming to Aryabhat first time, you may not remember all the things, but in 1 month, it is more than 1 month, 1.5 years, you have remembered so many things. You can say that shop is here, that shop is there. So similarly, if you want to learn the equation or even memorize, don't memorize, just solve it as many times without the target to memorize. Don't make a target, I have to commit it to memory. रटने की इच्छा को त्याग दो and then solve it as many times. Your brain will consume it. But if you make no, I have to रटना है, इधर आज इन होगा कल आउट हो जाएगा. ठीक है, चलूँ आगे. So last equation I will repeat from here. So what I got is 1 plus R1 by R2 is equal to C R3 plus Rx by R3 plus My L plus M plus Y. I could have solved it here, I could have multiplied here, but I am too much worried about that. So I am leaving it here as it is. I am solving first that. So that will be plus L plus M into Y. Now when it gets multiplied, it will come like this: R3L plus M plus Y plus My. Is it okay? It will come like this. Now you can see similarity. If I will take LCM, these two denominator will be common. So now I am coming to a more clean equation. So this is R3 plus Rx into L plus M plus Y by R3L plus M plus Y plus My plus L plus M Y by R3L plus M plus Y plus My. Because I am writing My, don't think it is only my equation, it is yours also. And don't think it is my. If you say my, it is yours. Okay. So, the equation is common. Okay. So, it is R3 plus Rx L plus M plus Y plus L plus M into Y by R3L plus M plus Y plus My is equal to 1 plus R1 by R2. So we have got nothing till this step. We are only reducing the jungle, we are cutting the equations, the creepers, the trees, and we are clearing the forest. Enough? Yeah, come. But now, here, from here I cannot reduce much. So from here I will go to my target. My target is to find Rx. So I will separate Rx from these. Okay? So to separate Rx, yeah, here is the Rx. So everything can go this side. Okay? So first what I will do, I will throw this to this. So this will be 1 plus R1 by R2 into R3 L plus M plus Y plus My. Okay? So after removing this to here, this remains. Now I will subtract this. So this will be minus L plus My by this term will remain. So this will be L plus M plus Y minus R3. R3 also remains. Minus R3. So writing again for you. This is R3 L plus M plus Y plus My. Writing on the upper half. Rx is equal to 1 plus R1 by R2 R3 L plus M plus Y plus My minus L plus M Y by Is it correct? Let me check. Okay. One change. I was thinking I did something else last night. I will not go this because it will again create some clumsiness. Okay, hold. I will go through this. I will just put it here. I will not again make a rational equation. I will make a linear equation. Okay, so for linear equation I will just put it here because other things will definitely cancel out. So R1 R2 into this R3 L plus M plus Y plus My, and now this is R3. So I will taking R3 L plus M plus Y plus Rx L plus M plus Y plus L plus M into Y. This. Okay. Because see, I want to get rid of this equation. This is a quotient form, rational form. So if I will again do the same process, again I am creating a rational form. It is better to look in this way because then I will get the terms to cancel out. Okay. That I did last night. Fine. So here let's do the calculation. This is 1 into this. So this is R3 L plus M plus Y plus M Y plus this is R1 R3 by R2 into L plus M plus Y. Let me write it again because I will write in one line. So implies I have to write several times because I have less idea to write on 4 by 5 by 4 fold. Sorry. Writing this R3 L plus M plus Y plus My plus R1 R3 by R2 into L plus M plus Y will be equal to R3 L plus M plus Y plus Rx L plus M plus Y plus Ly plus My. It is good. Here. हाँ ठीक है. Something I have left here. हाँ ठीक है आएगा. Good. Fine. So what I see, this and this cancels out. This and this cancels out. So under the Swatch equation, Abhiyan, we have eliminated more terms. So what remains? R1 R3 by R2 L plus M plus Y plus R1 by R2 My is equal to Rx So what will be Rx? Rx will be, see, I am dividing by this. L upon? I will come to that. Yeah, that there I am coming only. Now you get me. So this is R3 will be R1 R3 by R2 L plus M plus Y plus R1 by R2 My minus Ly by L plus M plus Y. Is it okay? So if I am okay, deleting this. Something I did wrong. It will come. See, I took time. Yesterday I took time. I went through 3 to 4 times calculation because last year I found some error in the derivation in the book. So I could not complete. I don't remember. I didn't make a fair. So it took me time to make a fair. I also did some wrong. I didn't reach in a one go. It took me time. But main thing is that I had a thinking process. So I will go somewhere. If you will not, if you will not have a thinking process, you will try something this, sometime this, something this, sometime this. You will not stick to one path. Okay. So I am saying to stick to the one path. So here we come. I will try to write in small font. So here Rx is R1 R3 by R2, because this will cancel out, plus R1 by R2 My minus Ly by L plus M plus Y. Okay. So if I will divide both sides by M, means multiply by M and divide by M. So I will get My here. Take out the My and you will get this. This you can do or not? Take out the My from here. Make the My common. So when I will multiply My, this will be R1 by R2 into My minus M will cancel out Ly. Here I come. So now what he said, that for R1 by R2 is equal to L by M. See, if I have not started with that condition, Kelvin's double bridge condition, still after here I want to just have this, and to have this has to be go 0, or for this term to become 0, this should be equal to this. So even if I will not impose the initial condition, you have to design the circuit to get this, so that Rx will be expressed in terms of R1, R3 and R2. So no lead resistance, no contact resistance. This will be more accurate than Wheatstone bridge. So here is the thing. Okay. If you are not knowing condition, you can impose condition here. So you can discard that thing from starting. If you have a problem, why I will take R1 by R2 as L by M, leave it. You come to this point and then you will realize that this is the error in my reading. If I want to know unknown, I have to take into account this. So if I want to cancel this ratio should be equal. For this ratio to be equal, I will get this equation. Okay. So that's the thing. Now I will go in a Hindi and will try to put on the same page. Okay.